Now we are at lecture 26, our very last lecture. I'm in the final exam unit, and here you can see we have a part 1 to the final exam, which my last lecture reviewed. So if you want to see that, you go to lecture 25. And today we're going to be looking at part 2. Now I really want to remind all of you about submitting your work. Sometimes students think they have submitted their work, but they have not. So make sure that you have this automatic confirmation email from Blackboard for successful submission, because the final exam especially, I would hate for any student to not get credit for their work because they don't have this in. And in this particular part of the exam, final exam part 2, it's show your work on every single problem, which means if you don't get this work into me, you're going to fail the exam. It's imperative that you do this. So if you want to be doubly sure, submit it to Blackboard and email it to me if you need to do that. But as long as you have your Blackboard's automatic confirmation email, you don't have to email it to me also. But if there's any delay at all in receiving this email, then please do go ahead and email it to me also. Okay, so without further ado, let's hop over to My Open Math. In My Open Math, I'm going to be looking at the copy of the practice exam used in lecture 26. Now, in the actual final exam, there will be a random order, but for the sake of this practice exam, it is not in random order. So just make sure you read any text that I post with anything that I post, because those paragraphs that I write are important. Okay. So let's go ahead and start with question number 1. A radio tower is located 450 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 43 degrees and the angle of depression to the bottom of the tower is 28 degrees. To the nearest foot, how tall is the tower? So this is worth 6 points, and the first thing we want to do is draw an accurate and fully labeled diagram. So first of all, we have a building and we have a tower, and they are 450 feet apart from each other. It does not matter whether the tower is taller or not than the building. All that matters is that the tower is taller than the window in the building, because all of this is in reference to a window in the building. One thing you do need to add to this diagram is right angles. Anywhere you would have a right angle, and it's an acceptable assumption in a problem like this that our tower and our building are at right angles to the ground. Okay, now let's look at the next part of the information. The next part of the information says that we have an angle of elevation to the top of the tower, and this is from the window, that's 43 degrees, and then an angle of depression to the bottom, that's 28 degrees. So what would that look like? So first of all, an angle of elevation and depression, we're going to go ahead and just make a single point in the window that we are using as our reference. They're both in reference to a horizon line, and the horizon line is always going to be perpendicular to any vertical components. Okay, so the horizon line is parallel to the ground. Now, from this same point here, we're going to then draw an angle of elevation which goes up from this horizon line to the top. And that angle of elevation is 43 degrees. And you can make this other line dark. I initially started with a dotted line just to show you that it is a horizon line, and a horizon line you can draw as a dotted line, you can draw as a solid line. But oftentimes you see them as dotted lines. But I want you to be able to see my diagram. Okay, so then next we want to look at the angle of depression. And the angle of depression starts at a horizon line and then goes down. So we're connecting then to the bottom of the tower. And the value for that was 28 degrees. And the question is saying, to the nearest foot, how tall is the tower? So that means that I need to figure out this entire height. But we're going to find the height of the tower as the sum of two parts. And I'm going to call my two parts x and y. And so I'm going to need to label x and y in my diagram. X can be from the top here of the radio tower down to this point where the horizon line intersects the tower, so that could be x. And then I'm going to have a different mark for y, and y is going to go from this mark down here, so that you can differentiate x and y. Having a little mark right here is a good way of showing where x stops and y begins. Now this 450 feet here is also going to be replicated right here because by forming these four right angles, we've created a rectangle. And so since opposite sides of a rectangle are congruent, we can say that this side right here is also 450 feet. That means that in our diagram now, we have two right triangles where we have known angles, one known side length, and then we're trying to find the missing side lengths. And so those missing side lengths can be found using SOHCAHTOA, which we're allowed to use because we have right triangles. So we're going to have one tangent equation for x and one tangent equation for y. Now technically everything I have on the board is adequate, so let me review everything for you. First of all, my diagram. I don't want you to lose any points on the diagram, so make sure that you have your right angles everywhere where right angles should be. Make sure that you have your diagram fully labeled, not only with the angles, also with this measurement here. Now the 450 feet does need to be up here, but it does not also need to be down there. I put it down there originally because we would expect to see it there, but as long as your 450 feet is right here, that's adequate. Make sure you pick two variables and include them in the diagram. Again, make sure that we have a right angle here. And then you need to somewhere say that the height of the tower is equal to the sum of the two variables. And you could represent that as just saying, hey, this whole thing right here is x plus y. Now, by me writing these two equations for tangent, that would be sufficient work for showing how to solve for x and y. If you do want to show additional work, that's fine. Additional work helps give you additional partial credit in case you get something wrong. But this is all you would need to do for the sake of a correct answer. Now, I will go further, though, and show you how to get the total height of the tower. The total height of the tower is x plus y. Now, x is 450 times the tangent of 43, and y is 450 times the tangent of 28. So if you add those two amounts together, you'll end up with your result. And when you go to find your answer, make sure that you do type both of these in together. If you find x and y individually, that is okay. You can then combine them, but don't round to the nearest foot if you find them individually. Instead, make sure you go out a few decimal places. Only round at the very end. By adding these two together at the same time, you will keep yourself from any rounding error. And so at the point you type both of these, and then you end up with 658.901, etc. And so 658.9 will round to 659. And that would be your answer. But if you round each of these x and y's individually to the nearest foot and then combine them, you could get the wrong answer. So again, don't round until the very end. All right, let's go to the next problem now. The next problem, question number 2. This is going to be a proof. Now notice for my directions I say prove the given identity, work out the proof on paper and include it with written work submitted to Blackboard. That means you don't upload it directly to the test. If your version of this question requires you to prove a variant of one of the Pythagorean identities, first convert all trigonometric functions to a ratio involving sine and or cosine, then simplify. Now this question is going to be one of several proofs pulled from a pool of proofs. And so your best option to prepare for question 2 is to go back to the video I made specifically about this question. So what you would want to do is you'd want to go back to Blackboard and you would want to find in the end of Unit 4, I posted a video right here at the end of Unit 4 during the sessions. It says Review of Proofs for Test 2 Question 4. This review of proofs for Test 2 Question 4, this video right here is going to be the video that you're going to want to watch in order to...
This is a special video for those of you who are struggling with proofs.
In order to get through the question on the final exam. This one right here is going to review several different proofs for you. So you're going to get to see me work through a proof of this kind. You can then see me again work through a proof of this kind right here. You can see also, hold on, this kind of proof right here. This kind of proof right here. And so I worked through a good number of the ones that you could actually end up with on the final exam. So I would challenge you to work through this video that I've already made and posted and try out each proof in advance of me working it out. That way you can compare what you really would have done without any assistance to how the proof actually should go. Now I do talk then at the end about the variance of the Pythagorean identity. This right here is what I'm talking about when I say if you end up with a variant of one of the Pythagorean identities, that you need to rewrite it all in terms of sine and cosine. You can't just use circular reasoning and say, this is true because it's one of the identities. So you do need to hash it out a bit. Okay, so going back now to the final, question number 3, use the cosine and sine sum identity, or use the cosine or sine sum identity to find the exact value of the sine of 255 degrees. So to do this problem, first of all, you want to have in your notes or just look in the back of the book the sine sum formula and the cosine sum formula depending on which one you get. So in this case we do have a sine. So what we want to do is we want to write 255 degrees as the sum of two angles that are actually on the unit circle. And so we could use 210 and 45. You want to rewrite this original line with the 255 degrees, or whatever number you get, split up into the two values that you're actually going to use. Then you want to include in your work substituting these particular values into this formula. So everywhere where I see an A refers back to the first of the two angles. In this case, it's 210 degrees. And everywhere where I see a B refers to the second of the two angles, in this case 45 degrees. So make sure you include that part of the work. Next, use the unit circle to replace each of these values with the value from the unit circle. So the sine of 210 degrees is -1/2. The cosine of 45 degrees is √2/2. The cosine of 210 degrees is -√3/2. And the sine of 45 degrees is +√2/2. And then for your final answer, you can go ahead and just combine these. -√2 minus √6 all over 4. Now it so happens that they've written it in the opposite order, but addition is commutative. So negative root 2 minus root 6 is the same as negative root 6 minus root 2. Okay, now for question number 4, this is a new one. This is one that you have not seen before. So there are a few problems on here, or at least a couple, that you've not seen before. So pay extra attention to these types of problems. In the write-up for your work, you may not use the inverse trig functions. That's very important. So let me show you how to do this without using inverse trig functions. First of all, let's go ahead and just write down the facts on the board. We're trying to find the cosine of u over 2. We are told that u is in the 4th quadrant, and we know that the secant of u is equal to 12.367. Okay, so here's what we know. Now what we want to do is we want to find the cosine of u over 2 formula to see what it is we need in order to move forward. Okay, so this is what I found in the very back of the book. I found the cosine of a over 2, and I found that it has a plus or minus, so I need to figure out if it's going to be a plus answer or a minus answer, and then also I'm going to replace every occurrence of a with u. So let's look at the original u value. The original u value, being in the 4th quadrant, means that u is between 2 pi and 3 pi halves. Now, if you divide this inequality by 2, the result is 3 pi fourths is less than u over 2 is less than pi. So what I want to do is I want to keep in mind that u over 2 is therefore between 3 pi fourths and pi, which would make u over 2 a 2nd quadrant angle. Cosine in the 2nd quadrant is going to be negative. Now you do need to include this, all right? So make sure that you write that somewhere. You don't have to write the original line, but you do need to write for me down here that you have shown that u over 2 is in the 2nd quadrant by this inequality. So once you've concluded that, you don't have to have this diagram. That's just there as a picture to help you visualize. Because we are in the 2nd quadrant, make sure you include that, we can conclude then that using this formula, we are only going to use the negative value. So we're going to rewrite this formula just for u using the negative value. Okay, and now that I've done that, I'm going to go ahead and erase this because you don't have to include this formula in your work. You just need to show me the variant of the formula that is a u over 2, not a over 2. Okay, so again, this work right here tells me why you don't copy the plus and the minus. You're only copying the minus part. So now what I want to do is I want to substitute 1 over secant u for cosine u. And my motivation for doing this is that I know what secant u is, but I don't know what cosine u is. The good thing is that cosine u and secant u are reciprocals, so I can just rewrite cosine u as a 1 over secant u, and then from here I'm going to do another substitution, replacing secant u with the value that secant u is equal to. And then from here we can use the calculator. So we can just type all that up into the calculator. The result is negative 0.73513, etc. You can see that this 3 does not change the 1 when you round to 4 decimal places. So on the board I just wrote negative 0.7351 as the final answer. So there's the work for question number 4, a brand new problem, but nothing you haven't seen before in terms of a concept. All right, now let's go on to question number 5. Question number 5, we're going to be solving this equation right here for all solutions between 0 and 2 pi. We're going to give answers accurate to at least 2 decimal places as a list separated by commas. Alright, so let's go ahead and put that one on the board. Before we start working on the algebra of solving this equation, the first thing we're going to want to do is rewrite sine of 2t in terms of sine and cosine of t. We don't want to have a double angle and a single angle in the same equation. So we're going to use the fact that the sine of 2a is equal to 2 sine a cos a. I got that out of the back of the book. And we're just going to rewrite this, replacing the sine of 2t now. So I just replaced the sine of 2t with 2 sine t cos t. Now this is a 12, and you can rewrite it again if you would like with the 12. But make sure you go ahead and show the substitution without making it a 12 first. Include the 2 sine t cos t in your rewrite so that I can see that you made the substitution. Don't jump immediately to 12. You're showing the use of this formula right here. Okay, next we're going to factor out our GCF. And if you have a 12 and you have a sine t and you have an 8 and a sine t, then you have a GCF of 4 sine t. So you can go straight to 4 sine of t being factored out. And then that is then going to give you, since 12 divided by 4 is 3, 3 cosine of t minus 2. And you do not have to show the intermediate step of 6 times 2 is 12. Okay, from here we're going to use the zero factor property. So 4 sine of t is equal to 0, and 3 cosine t minus 2 is equal to 0. The result of that is that you end up with the sine of t is equal to 0. And the cosine of t is equal to 2/3. So now what we want to do is we want to look at the unit circle. So I'm going to draw a unit circle. I'll go ahead and just draw it over here. Where do we have the sine of t equal to 0? We're at 0 and pi. We want all answers between 0 and 2 pi, but not including 2 pi, so we use 0, not 2 pi. So those are the solutions for sine t is equal to 0. Cosine t is equal to 2/3. 2/3 is about right here on the x-axis, so we have one dot up here in the first quadrant, and then we have another one down here in the fourth quadrant. So at this point, we want to use the inverse function. And notice that we are in radians. So when you're using your calculator, make sure that you are in radians, not degrees. And I'm going to do the cosine inverse of 2/3. And I get the value 0.84. I'm just going to 2 decimal places according to the directions. Now this value right here is going to be 2 pi minus, and you want to use the extended decimal in this case, 0.84106 ... Use the extended one because you want to round after subtracting the value from 2 pi, since 2 pi is not a rounded answer. So the reason I am doing 2 pi minus that value is that the angle right here formed this 0.84 radian angle is congruent to this other angle down here, which is also then 0.84. And so since these two angles are congruent, we can get to this dot right here by taking 2 pi and then subtracting the 0.841, etc. So I'm going to just go to my calculator and say 2 pi minus the answer. And then that is going to be to 2 decimal places 5.44. So I have a 0, a 0.84, a pi, and a 5.44 as my final solution set. I'll go ahead and write them down here. Now, if you are writing all of your solutions over here on the circle, you do not also need to list them out. You do need to show that t is equal to these values at some point. But then you're going to write your final answer online. So here we have 0, pi, 0.84, and 5.44. You see that they did not write them from least to greatest as I did. And you can go further than 2 decimal places. It's accurate to at least 2 decimal places. So it doesn't matter if they are from least to greatest or not, as long as you have them all listed out, separated by commas. Question number 6. Solve for the exact solutions in the interval from 0 to 2 pi again. This time, though, we're looking for exact solutions only, no decimal approximations. If the equation has no solutions, respond with D and E does not exist. Okay, so let's do this one on the board. So how do you solve a problem like this? Well, first of all, you want to ignore the 5x and just think of this as, don't write this down, but just think of it as a cotangent theta is equal to root 3 problem. Try to isolate the outside part first in your mind. Ignore the 5x for starters and just think of that 5x as some angle. You want to ask yourself, where on the unit circle do we have a cotangent value of root 3 over 2. And again, this is not part of your work. This is just part of your thought process. Remember that cotangent is going to be x over y, right? Tangent is y over x. Cotangent is x over y. And so what I want to do is I want to think about all the x-y pairs going around the unit circle. And when I think about values, all of the values are limited to just a few numbers. We've got 0, plus or minus 1/2, plus or minus root 2 over 2, plus or minus square root of 3 over 2, and plus or minus 1. So we've only got a handful of values. Of those, only one that has a square root of 3 in it is going to help us get a square root of 3. So that's going to limit us to values that have a root 3 over 2, and those occur at just a few places, but every time a square root of 3 over 2 occurs, a 1/2 also occurs with it, or plus or minus of thereof. So since we want this to reduce down to root 3 over 2, that means that we needed this ratio to be a square root of 3 over 2 over 1/2, and that ratio would reduce to square root of 3. So if you find it helpful for your notes in advance of the final exam, you can go through and write down all the tangent ratios and all the cotangent ratios on your unit circle so that you have all of the tangent ratios and all of the cotangent ratios beside the points so that you can see sine, cosine, and tangent all at once by looking at the unit circle. That's up to you. All I needed to do in my mind was figure out that the point I'm looking for is square root of 3 over 2 comma 1/2. Also, this point over here would also fulfill the bill because this one is negative root 3 over 2 negative 1/2, and that would also yield that same root 3 ratio. So the reason I don't actually need this one, though, is because if I figure out that pi 6 is one of my answers, then I can just add multiples of pi to pi 6, and that would generate all of my possible values. So what I'm getting is that 5x has to be equal to pi 6, that theta value, so to speak. Theta was just a dummy variable I threw in there. But that theta value has to equal pi 6 plus multiples of pi. So you don't actually have to include 7 pi 6 right away. it would just be redundant. You'd end up with the same answers generated eventually anyway. So just focus on the main one, pi 6. So you can see that every multiple of pi, you're coming around to one of your answers. So this would be your next line of work, to say that the angle is 5x, is equal to pi 6 plus every multiple of pi will generate that answer. Next, you divide by 5 because of the 5 right here. So divide everything by 5. And the result, and you don't have to show that divide by 5, you can divide by 5 in your head. The result is that x is equal to pi 30ths plus pi 5ths k. Now, if it's helpful for you to go ahead and get a common denominator, you can. So you could say that this is also going to be x is equal to pi 30ths plus 6 pi over 30k. 6 pi over 30 is the same as pi over 5. I just made sure that the denominators were the same. The purpose of this is I'm going to go ahead and start generating solutions. And I get to go all the way from 0 to 2 pi. So my first answer is pi over 30. And now I'm just going to add multiples of 6 pi over 30. So I'm going to start with 6 pi over 30, and then 12 pi over 30, 18 pi over 30, 24 pi over 30. I just keep adding on multiples of 6 pi over 30 to the previous answer. I just keep adding 6 pi over 30. So 6 pi plus 1 pi is 7 pi. Plus another 6 pi, 13 pi, plus another 6 pi, 19 pi, plus another 6, and another 6. When do I stop? I stop if I go past 2 pi. Now 2 pi is the same as 60 over 30 pi, right? 60 over 30 is the same as 2, which means I got to keep going until I was going to pass 60, and I'm at 31 right now. So keep adding 6, 37 pi, 43 pi, 49 pi, 55 pi. Now, if you add another 6 onto 55, you end up at 61. And 61 over 30 pi is coterminal with pi over 30. So at least you know you didn't make a mistake in your addition there. Okay, so now let's go to the MyOpenMath result. And you can see that all of these are listed out. You got your pi over 30, 7 pi over 30, 13 pi over 30, 19. What happened here is that I ended up with a 25 pi over 30. You can see it right here. 25 pi over 30. So this 25 pi over 30 reduces. So you want to list it as a reduced answer. And let's see, are there anything else that reduces? This one right here at the end, 55. Those are the only ones that reduce. So in the list, they all of a sudden drop down to a denominator of 6, and that's because you have a numerator and a denominator both divisible by 5. So here you see them, 5 pi 6, 31, 37, 43, 49, and then instead of 55 pi over 30, 11 pi over 6. So that was a big problem. It's worth 4 points, so it's actually not the most important problem, but of course you don't want to lose 4 points on the final exam. So do your best to learn it and rewatch that if you need to. Okay, so next let's look at question number 7. Okay, so for question number 7, there's actually 2 different ways of solving it. One of the ways of solving it is shown to you in the written example. And this written example uses tangent and a very nasty substitution. This same method is shown to you on page 85 of your textbook. So they show you how to do that really long, yucky substitution. And so you are welcome to do this method. And this method relies only on SOHCAHTOA, so you can go through page 85 and learn this method if you like. Alternatively, I will show you some other way of doing it that you may prefer. So in this video, I will show you a method not like what you learned in Chapter 2, but instead relying on your new knowledge from a later section. First, either way, you have to have a good diagram. So let's go ahead and get the diagram set up. To estimate the height of a building, 2 students find the angle of elevation from a point at ground level down the street from the building to the top of the building. Down the street from the building. Okay, so they find the first angle of elevation to be 33 degrees. Then, from a point 350 feet closer to the building, the angle of elevation has now increased to 49 degrees. If we assume that the street is level, as a good assumption, use this information to find the height of the building to the nearest foot. So I'm going to start by drawing the diagram. So I'm starting with the street, and the street is at a right angle to the building, so include that. From the first point, the angle of elevation to the top of the building ends up being 33 degrees, okay? Then the students move down the road. The fact that there are 2 students is totally not necessary to know. You could have 5 students or 1 student. Either way, it's going to be the same problem. I think there might be 2 students because there are 2 dots. Okay, here we have 350 feet. Now, moving forward 350 feet, same procedure is done again to find the angle of elevation. And this time the angle of elevation is found to be 49 degrees. So just based off this, we need to find the height of the building. So, if you know law of sines, you can get quite a ways through this problem a lot faster than the yucky method from the book that I had just shown you. And what we want to do first is make the observation that this angle right here is supplementary to this 49-degree angle, right? They form a linear pair. So this angle right here would have to be 180 minus 49, which is 131 degrees. So now I have a 131 degree angle. All right, so lastly, in this outer triangle, then I can find the top angle. Remember that the 3 angles of a triangle add up to 180 degrees. So we simply subtract these from 180 and we end up with 16 degrees. Alternatively, you can also note from geometry that an exterior angle of a triangle is equal to the sum of the 2 remote angles of the triangle, so that 33 and this angle here must add up to 49 degrees. Either way, you need to figure out that you have a 16-degree angle there in order to use law of sines. Now, the side that we want to find ultimately is this side over here, h, which is not even part of this outer triangle. So if we can find the hypotenuse of the right triangle, then that would get us over to that right triangle. But right now we know no side lengths for the right triangle, so we can find the hypotenuse using this exterior triangle using law of sines. So I just need to give it some sort of variable. Good old-fashioned x. Okay, so now I set up the law of sines. Now I should note that because you can find this 16-degree angle here using the fact that 49 is equal to 33 plus that 16-degree angle, it is not necessary for you to label the diagram with this 131-degree angle. This 131-degree angle is not required. What is required is that you include that 16-degree angle up there at the top so that you can use law of sines. This would give us x. So I'm going to hold off on finding a value for it just yet. I want to come over here and say, if I knew what x was, which would I use? Sine, cosine, or tangent? Well, this is the hypotenuse. This is the opposite side, so that would be sine. The sine of 49 degrees is equal to opposite over hypotenuse. So that means that h is equal to the sine of 49 degrees times x. Now I should point out that this is required work, this is required work, but this one is not. I can go from here to here just fine. Alright, so what I want to do though is go ahead and get an approximation for x. So I'm going to do 350 times 33 degrees divided by sine of 16. I'm sure by this point you know how to solve a proportion. And I end up with a negative number. Why? Because I'm in radians. So I need to, if you get a negative number for x, that's not good. So if that happens, that's a good alert where you say to yourself, oh yeah, I need to be in degrees, not radians. Note to self. Always, I don't care if you have a sticky note on your computer, whatever you need to do, check the mode on your calculator before you do a problem on your calculator. Okay, let's do this again, this time using degrees. Aha, much more reasonable. X is approximately, and remember, x should be bigger than the height of a building, right? Because x is the hypotenuse of this triangle. So make sure your x value is bigger than the height of the building. And if you end up with a 4-foot building, that's a problem. Okay, this is about 691.57 ... I'm just going to use this over here so that when I have sine 49 times x, I'm just going to take the answer in my calculator now and multiply it times the sine of 49. So this one ends up being 521.9376 ... which would round to 522 if I'm going to the nearest foot. Okay, so this would end up being a 522-foot building if you are rounding to the nearest foot. Great. All right, now let's go on to question number 8. This one should look very familiar to you because you just had it on test 3. So if you rocked it on test 3, awesome. You can do that again on the final exam. Some of you were pretty good with this question, but you drew your diagram incorrectly, which threw off your problem tremendously. So the diagram is worth half the points on this problem. An airplane is heading north at an airspeed of 800 kilometers per hour. That's going to be the same in every problem that you have an airplane heading north. What changes from each variation of the problem is where the wind is blowing from. The wind can be blowing from the northeast, the northwest, the southwest, the southeast, and depending on where the wind is blowing from, this will change your diagram considerably. So let's look at this problem right here. So here's the airplane heading due north. Here is my wind coming from the northeast. So when you draw this, you have to be very careful about what your parallelogram looks like and which diagonal you choose for your resultant vector. And that's the biggest stumbling point. And some of the problems are a little easier or a little harder depending on where the wind is blowing from. In this particular version, remember the wind is blowing from the northeast, so you can also duplicate this vector right here And regardless of where you write it, as long as you're coming from the northeast and it has a length of 60, it's going to be the same vector. Here we have a 45-degree angle that is formed from the northeast. And if you end up with an acute angle, you're going to keep that 45 degrees. If you end up with an obtuse angle, don't label it 45 degrees. The obtuse angle that corresponds to 45 degrees is 135 degrees. Now, the resultant vector is going to be over here on the left-hand side, so I'm going to move the 800 over to the right. And pay attention now to the resultant vector. I would suggest you do multiple variations of this particular problem with the wind coming from different directions because it will greatly change your diagram. So, I need to figure out this new value here. This is the actual path of the plane, and so I need to find out its new speed. Notice that if the wind is coming from the northeast, that should make the plane go slower. So pay attention to whether or not the plane would be going faster or slower depending on where the wind is coming from. Is the wind working against the plane, or is the wind helping the plane? And then this would be a law of cosines problem. Okay, so for the law of cosines, you only need to show this much work, and then you can go straight to your answer. And then the other thing we need to find out is how far off course the airplane is going, and so you do need to add another variable to your diagram. I will go ahead and just call this angle theta, and then to find this we use a law of sines. So we have that the sine of 45 degrees over x is equal to the sine of theta over 60, and then that would be the work for that, and then you're going to go ahead and figure out what the sine of theta is equal to. So you do want to have sine of theta next as your next line of work. So I'm going to take the sine of 45, multiply it by the multiply it by 60, and then divide by my answer that was already in my calculator. And this will tell me that the sine of theta is about 0.0559. And now I'm going to figure out what theta is approximately equal to using inverse sine. And I end up with about 3.205. Now I need to see what is it that I need to round to. And on my open math, it says that we're rounding to the nearest tenth. So for this one we would do 3.2. And then for this one right here we would do 758.8 because the 6 rounds the 7 up to 8. Okay, now we're down to this very last problem, which was also from the last test. Find the angle between the vector in degrees. So this should be another familiar problem. So first I have up here what the dot product is. If vector u is a comma b and vector v is c comma d, then the dot product of vectors u and v is going to be ac plus bd. So I want you to show me the work of finding the dot product. You do not have to write that formula as part of your work. Just include the work for the dot product. So the work for the dot product would be that a dot b is equal to 4 times -1 plus -1 times 3, and that's going to be a total of -7. So once you show me the dot product, then we can use the geometric interpretation of the dot product. And so we need to also know the magnitudes of vectors a and b. So you can state that the magnitude of vector a is going to be the square root of 4 squared plus -1 squared, which is the square root of 17. And then the magnitude of vector b is equal to the square root of -1 squared plus 3 squared, which is the square root of 10. So now coming over here, we are looking at cosine of theta is equal to A dot B over magnitude of A, magnitude of B. Notice I'm taking the original formula and I'm applying it to my specific vectors. So A dot B is -7, and then I have the product of the two magnitudes, so root 17 times root 10, and then this is going to be equal to approximately -0.5368, etc. And that is the cosine of theta. So then theta itself, we need to use inverse cosine. So use inverse cosine now. To get approximately 122.47 degrees. Now let's make sure that the answer makes sense. Look at A and B. A is 4, -1, and B is -1, 3. Does it look like the angle between these two vectors is 122 degrees? Yes, that's reasonable. So make sure your answer is reasonable given where you know your vectors actually are. So now if we hop over to my open math, to the nearest tenth, we're going to have 122.5 as the answer. And that's it. Wow, the last lecture. Well, I have been really enjoying this course, even if I haven't got to see you, which has been the most disappointing part. I hope that you have enjoyed it too, and I hope that these video explanations are really helpful. Now just keep in mind that when you get to the final exam, the questions will be shuffled. So practice the version of the practice exam that has the problems shuffled, and that will help you tremendously. Okay, I hope you all have a wonderful day.